Hello my dear students, how are you all? Welcome to our YouTube channel Diksha Karnataka. I hope all of you are doing very good. Today is our day 20 of our ongoing series, which is 60 out of 16 KCET mathematics in 100 days. I hope all of you are filled with energy, ready for the session, right? What is the today's session agenda? Today's agenda is nothing but your PYQ. Okay, so what we're going to do in today's session is we'll talk about continuity and differentiability. Okay, so we have done the chapter, we have completed the chapter, we have done the revision also, we have done more questions as practice in the revision as well. Today's session will talk about only PYQs. Okay, so let's see, solve them, and next you'll have mock test. I think next mock test will be KPL 3. In that you'll have chapters determinant coming and few questions from continuity and differentiability. So prepare accordingly. Okay, so major questions will be coming from determinants. Okay, I think around 20-25 questions, and few questions will be coming from continuity and differentiability. Okay, so prepare like this. Total 30 questions will come, 20 odd from determinant, other 10 from continuity and differentiability. I hope this is clear. Okay, all right, so let's start with the session. We'll do only PYQ, no concept is here. If something is coming while doing the problem, then I'll explain that concept at that point only. So let's begin with the session. The first coming up is, first question is, okay, so if y equals to tan inverse of x the whole square, then we have to find this value. Okay, question has been asked in 2014. Okay, this is the given condition for the function y equals to tan inverse of x the whole square, and this is my condition statement. Means you have to put the value of this in this statement and find it, what is it equal to. Let's see how will this pan out. Okay, so first thing is, let's find out the values of what. See what is they are asking. They are asking us, very important, y2 and y1. If you remember the signs I gave you how to represent differentiation, it was either y dash, y double dash, or what was it, dy by dx, or d square y upon dx square, or it was y1 and y2. So y1 means first derivative or first differentiation, second means second order derivative. Okay, I hope this is clear, Bacha. All right, let's continue with the problem now. Let me just erase the extra part. Okay, yes sir. So first find the first derivative. Very simple, we can do it, right sir? Y is given equals to tan inverse of x the whole square. Okay, so how many functions will be operated here? First it will be polynomial function, means even this is a variable, tan inverse x is a variable, so I'll operate that for polynomial function. So that will look like this. Y1 will be looking like 2 times of tan inverse x. Is this over? No sir, I have to do for tan inverse also. Correct, I did for this whole square I did as 2 tan inverse x, and for the inside part tan inverse x I wrote it as 1 plus x square. Okay, this is my y1, which is first derivative. This part is clear, right? Yes. Okay, this is just the product. Okay, this is just the product, not the x as a variable, just the product. Okay, let's move on. To avoid the confusion, I wrote the bracket only, no problem. So now what I have to do, I have to put it here, but before going to do that, let's find y2 value. Let's find y2 value. What will be y2? Again, derivative of the first derivative. I have to again take the differentiation of the first derivative. If I do that, look like this, d by dx of 2 tan inverse x upon 1 plus x square. Now looking at this, you can give me the answer. Quotient rule, take the 2 out, take the 2 out. If I take the 2 out, what I'm going to get, please check. First I'll do for tan inverse x, I'll get 1 plus x square. I'll keep the second part as it is. Okay, understand this, only numerator I've differentiated. Okay, this 2 I've taken it out over here. Then comes what, minus sign. I'll keep tan inverse as it is, and what I'm going to differentiate, 1 plus x square. How much that will come as? For 1 I will get 0, for x square I'll get it as 2x. I'll get it as 2x. So this differentiation is over. What's the denominator? 1 plus x square the whole square. 1 plus x square the whole square. Let's simplify. Yes, something is getting cancelled, right? This whole thing will get cancelled. Okay, now what I have left now, I can simplify this y2 as 2 times of, please check here, this is simply 1 minus 2x tan inverse of x, right bacha? Right? Yes sir. Yes sir, it is right. Correct. Now I can write 2x first. So this is my y2. I have y1 and y2 value. I'll substitute in the expression that I have. Let me write it in the next slide. X square plus 1 the whole square times y2. X square plus 1 the whole square times y2 plus 2x times x square plus 1 times y. 2x times x square plus 1 times y1. Please check again. X square plus 1 whole square y. Yes, 2x times x square plus 1 y1. Correct. This is y2 bacha. This is y2. Let me continue with this here. What did I get as y2? I got y2 as 1 minus 2x tan inverse of x upon x square plus 1 the whole square. Right? Please check. 2 times. Okay, I missed this 2. This 2 is already also there. So I'll write this 2 here. Okay. This 2 is also there. Oh, better. I'll write this 2 out in front of everything. So I can write it here also, right? This 2 is written up front. For just for this term. For y2 has 2 in it. This 2 I wrote it in front. 1 minus 2x tan inverse of x upon x square plus 1 the whole square. Next what I will write? 2x as it is from here, and this will come as x square plus 1. What is my y1 bacha? Y1 was simply tan inverse of x with 2 upon, what is it? 1 plus x square. Please check. 2 tan inverse upon 1 plus x square. Please cancel this. Okay. Cancel this. Okay. Now, let's see this. How will this look like? I will have, what will I have? I have 2 left, this 2. I have 1 minus 2x tan inverse of x left, right? That's it. And then what I have left? Plus 2x times of, what bacha? 2 tan inverse x left. Please check. Anything else is left? All cancelled, right? Only this part. This and this is left. Over here, this bracket and this 2 is left. So what I'm going to simplify this as 2 minus 4x tan inverse of x, and over here also what I'll get? 2x times this. So 4x. Yes. What's my answer? 2. What's my answer? 2. Option number C. Option C is my correct answer. Please see. Okay. I hope this is simple. I found the value of first derivative y1 and y2, put it back in the equation that they were asking us to find, the expression that they were asking us to find the value for. The answer is 2. I hope this is visible and clear to you. Let's move on. Question number 2. The function represented by the following graph. The graph is given here. Okay. For this graph, you have to identify whether it is, okay, continuous, differentiable. So all this condition we have to check. Basically, we have to check for what? Continuity and differentiability. Do I need to check for continuity? I don't need to, right? Please check here. It's a continuous graph. Okay, so there's no break at any point. At which point they're talking about? At the point 1. There's no break. Okay, so it is a continuous function. I don't have to check that. Okay, so wherever it is not continuous, that option is out, right? Not continuous. So option B cannot be there. Option D cannot be there. Option A and C we have to check. Option A and C we have to check. Okay. So basically continuity exists. We have to check for differentiability. How we check for differentiability? Any idea? Any recollection? Yes, sir. Only if I have LHD equals to RHD, I can say function is differentiable. Is differentiable. Correct? Function differentiable only if LHD and RHD are equal. Okay. Before going to do that, let's define the function at 1. So what will happen to the function at 1? Achha, what is this function? Any idea? Isn't this function basically y equals to mod x move towards right? What is this function? Y equals to mod x moves toward right. How much? 1 unit. It was actually placed over here at origin. Now it is placed over here at 1. So move towards right. What happens in the transformation? Y equal to mod of x minus 1. Correct. Now, if I am moving a graph towards right, the transformation is x minus a unit. Whatever is the number of units you have moved. So, number of unit moved here is 1. In that situation, I will write it as y equal to x minus 1. This is the function's graph now. This is the function. The graph of this function. Sorry, the function of this graph. I mean, y equal to mod of x minus 1. Let's define it. Let's define it at 1. I hope this is clear now. This part is clear. Okay. Okay, so let me write the function again. y equals to, what will this be, bacha? Please check here. So if I can define function at 2 point, x greater than equal to 0, greater than equal to 1, or x less than 1. Tell me what will happen at x greater than 1. X greater than 1, the mod will open with a positive sign, correct? So it will be simply x minus 1. What about x less than 1? The mod will be opening with a negative sign. So basically it will be what, bacha? Negative of x minus 1. So what will be 1 minus x. So I can replace this with 1 minus x. I hope you can understand this. Okay, simply 1 minus x. So now function is defined. Why I wrote it like this? Because what will happen, if I would have used directly for LHD as 1 minus x, will be confusing for you. So what I have defined the function now. So when I am finding for left hand derivative, I will use which function? 1 minus x. When I am finding what derivative? Right hand derivative, I will use function x minus 1. This is clear? Why did I do it? This is clear? Let's define it. Let's define LHD and RHD. Let's do for LHD first. So what is LHD, bacha? Please check. LHD is defined as limit x tends to what, bacha? X tends to 1 minus. Simply I can write this as, I can also write this for this what? Function fx. I can write this as, okay, no. Not limit, right? I'm not LHL. I wrote for LHL. I have to write for LHD. Left hand derivative. Please remember left hand derivative. How is this? Simply I can write it as limit s tends to 0, okay, f of 0 minus h minus, okay, f of 0 upon minus h. Please understand this. F of 0 minus h, okay. The value is not 0 in this case. It is 1. It is 1 because we are finding the derivative at 1, right? Please check. We are finding the derivative at 1. X equal to 1, we are finding the derivative. So not 0 minus h, simply 1 minus h. Okay, this is clear. Okay, let's use the function. For LHD, which function will I use? I'll use this one, 1 minus x. I'll use 1 minus x. Please understand this. So if I write it like this, I'm going to replace this by what? 1 minus, and wherever the x is, I'll replace by 1 minus h. So 1 minus h minus f of 1 means what? What is it? 1 minus 1, right? Because I will replace x by that value, no? So x will be 1 minus 1. Because the function, what is the function I'm using? 1 minus x. So replace x by 1. I write here as minus h. This is my limit h tends to 0. Okay, continue with this, please. Limit h tends to 0, 1 minus 1 plus h. This is simply 0. 0 upon minus h. Cancel 1 and 1. What I get? Limit plus h upon minus h, where h tends to 0. Cancel h and h. What I'm leaving with? Minus 1. What's my answer? My LHD, my left hand derivative is negative of 1. Negative of 1. What about RHD, bacha? Please check. What about RHD? For RHD, what I'll have? I'll have it as f of 1 plus h, okay, minus f of 1 upon just h, limit h tends to 0. Correct? This is for RHD. Which function I will use here? X minus 1. This is my function. Please check. X minus 1 is my function. Okay. Now if I'm using x minus 1, I'll write this as replace x by the f of 1 plus h. This x will replace by 1 plus h. What I'm going to get here? Please check here. So I'll get it as, I know it's getting lengthier. It's okay. Just a second. 1. So I will write it as 1 plus h minus 1 minus. So simply 1 minus 1. Again what? H. This will be 0. Okay. I'll write it as again this and this is 0. What is it? Limit of h tends to 0 equals to h upon h. How much is that? 1. So what is the answer? 1. So what is my RHD? RHD is equal to 1. So what it means? LHD is not equal to RHD. How, sir? LHD was coming as negative of 1. Please check. LHD was negative of 1. RHD is 1. Not equal. It means which option is correct? Not, okay. Continuous but not differentiable. That is option A. Option A is my correct answer. Option A is my correct answer. Moving on. If fx is given by this condition and they have also called it as continuous, the function is continuous. Please check. The function is continuous. Okay. At x equal to 0. So when can I say a function is continuous? If, sir, my left hand limit L1 is equal to right hand limit L2 is equal to function's value at that point f of 0. What is f of 0, sir? Please check here, function of x when x is 0 equal to 2k. It means f of 0 is equals to 2k. Very simple. Yes, okay. F of 0 is 2k, no problem, sir. Alright, moving on. So I don't have to find both L1 and L2. If I can find any one of them, they have already given it is continuous, means it's presumed that L2 will also be equal to L1, right? So L1, if I can find it out, if I can find my left hand limit and put that value equal to 2k, I can find the value of k. Then I can find the value of k. Yes, yes sir. Alright, let's check here. So let me find the L1 value. So L1 will look like this. If you remember, limit h tends to 0, I'll replace everything by 0 minus h because left hand limit we are finding it out. So wherever is x, replace it by 0 minus x. So sine pi 0 minus x, sorry, h divided by 5 times of 0 minus h. Let's simplify it. So limit h tends to 0, how much is that? 3 times of sine pi times minus h upon minus 5h. Please check here, minus 5h. So how will this look like? Okay, if I'm writing it again, so limit h tends to 0, okay, how will this be? 3 sine minus pi h upon minus 5h. Please check here, please check. Minus pi times of minus h is minus pi h upon minus 5h. Let's write it over here. What I'm getting here, limit, how much is it? H tends to 0, 3, okay, I'll write this statement again, minus pi h upon minus 5h, okay, minus 5 upon minus pi h upon minus 5h. This is h bacha, this is h, okay. Chaliye. Now what, sir? Sine inverse of negative will be what? Sine of negative will be simply, I can take the minus sign out, right? So limit h tends to 0, minus 3 sine pi h upon minus 5h. Please understand this. Sign of negative number, I can take the negative out, right? Negative will come like this, okay? So this negative and this negative will cancel each other. Now please check, to have this formula, remember this, sine limit of or h tends to 0, if it is sine ah upon h, if I have a here, then this will be equal to 1, right? This will be 1, right? Okay, so think about it. What is missing here? Pi is missing, no? So I'll multiply pi both up and down. Now what will this transform into? Limit 3 by 5, what is it? Sine pi h upon pi into h. Please see here, I have taken 3 and 5 outside, sine pi h upon pi h, where h tends to 0, okay. I'll write 3 by 5 as it is, okay, and this pi is also there, this pi, okay. This pi in the denominator comes here with h, becomes pi h, but I multiplied pi on both sides, right, up and down. So I wrote pi as it is in the numerator. Now what is left now? 3 pi by 5, and if you apply a limit to this thing, it will become what? 1. So what is my L1? My L1 is coming as 3 pi by 5. 3 pi by 5. We know that L1 is equal to what? F of 0. For it to be continuous, what is my F of 0? 2k it gave. Find the k value. 2 will come here, becomes k equals to 3 pi by 10. 3 pi by 10. Right? I can bring this 2 here, becomes 10. Okay. Okay. What's my answer? 3 pi by 10. Any option is there? Option B. Okay. Okay. Can we move on to the next question? Let's try. Okay, sir. All right. Similar question, but simpler. Why simpler, sir? Because for RHD, I can directly get what? 2k. I don't have to substitute and use the limit. Okay. What's the function value? It is given what? Continuous, find k. Continuous, find k. Basically, L1 equals to L2 equals to f of 5 has to be true for it to be continuous. What about RHD? Sorry, what about RHL? Please find it here. What about RHL? What is RHL? Simply 2k, no? Because after 5, what I'm going to get? What is the value? There is no variable here. So 2k is my answer. RHL is 2k. And what is f of 5? Tell me, what is f of 5? There is the equality present here. Please check. Equality is there. Less than equal to means I can simply write x as 5. 3 times of 5 minus 8. How much is that? 15 minus 8. Okay, how much is that? 7. Put it here. RHL has to be equal to f of 5 for it to be continuous, right? So what is RHL? 2k is equal to 7. K is equal to 7 by 2. Correct answer is B. Simple enough? Simple enough? Correct answer is B. Okay, let's move on. Simple question, very simple question. Okay, similar to that we solved the third question, so that's why fourth I kept it like this. It came in which year? 2015. Okay, and the other one came in 2014. So similar questions means basically you can, if you know the concept of one question, no, similar is expected, you know, in the coming years. Okay, so that's why you can see here the pattern is being formed. Now what is there? Y equal to log of, those questions were on differentiability and continuity. Now I think this is on differentiation, came in 2015 again. So I told you, know, this chapter has 4 to 5 questions weightage every year. Okay, 5 questions, minimum 5 questions is coming from this chapter. Very important chapter. Your whole calculus is important, but this is again building block for other chapters. Also questions coming from here, so very important. Chaliye, so y is given as this. We have to find dy by dx. Kar lenge? Can we do it? Yes sir, of course we can do it. Let's see how we can do it. So this will come as dy by dx. I have to use first for log, then I have to use what? Chain rule, then I have to use quotient rule. Check here. For log will be correct, only for log I did. Then I have to use what? For chain rule I have to use. For chain rule I have to do this part. Differentiation, I'll write it as t by dx of 1 minus x square upon 1 plus x square. Yes or no? Yes. Yes sir. Correct. Now what I'm going to do next? Please tell me. I will do what? I'll take this part in the numerator. It will become 1 plus x square upon 1 minus x square. So let me write it here. 1 plus x square upon 1 minus x square. This is okay. This part is okay. Now for the differentiation I have to use what rule? Quotient rule. I have to use quotient rule. So let me do it for the first numerator. I'll get this as minus 2x. Correct now? 1 will be 0, minus x square will be minus 2x. And I'll keep 1 plus x square as it is. Correct? A minus sign will come for the quotient rule. I'll keep 1 minus x square now as it is. And do for 1 plus x square. How much is that? Simply 2x. Simply 2x bacha. Correct? What is the denominator? The square of the denominator. So 1 plus x square the whole square. 1 plus x square the whole square. Okay. So can we simplify it over here only? Not required. Let's just take 2x common. I'll write it over in the next step. dy by dx is equals to what? 1 plus x square upon 1 minus x square, I think. Please check. Yes. Now I can take, please look at here, I can take minus 2x common. Can I not take it? Please check here. Minus 2x is over here and this is also over here. So minus 2x I can take common. How will that look like? Minus 2x is taken common. What is left now? I have just 1 minus x square, I think. No, 1 plus x square, I think. 1 plus x square is left here and that is plus sign now. This is plus sign now with 1 minus x square. Whole thing by 1 plus x square the whole square. Please check again. Yes, I've taken minus 2x common, so that's how it look like now. Okay. So if you check it here, this two will cancel each other. Correct? What is now I'm left with? 1 plus x square upon 1 minus x square times minus 2x upon, sorry, minus 2x times 2, right? 1 plus 1 will be 2. 1 plus x square the whole square. Cancel this with this extra. Okay. What is left now? dy by dx equals to, please check here. This is 1 plus x square the whole square in the denominator. 1 plus x square is over here. I can cancel one of them, right? What is left now? Minus 4x in the numerator upon 1 minus x square times, this is what? 1 plus x square is left. Correct? This is left, no? Okay. What is the final answer now? dy by dx equals to minus 4x upon a minus b, a plus b, a minus b, a plus b, simply 1 minus x power 4. I think this, see, 1 minus 4x, 1 minus x power 4 minus 4x 1 minus x power 4. Option C is correct. Okay, simple. Let's move on. We are only dealing with what bacha today's session? PYQ. Only PYQ we are doing. I didn't do for other chapters because I was doing in the your mocks, but I wanted to do some questions in PYQ over here also before going into the mocks. Okay, chaliye. Before going into our KPL. Now, this is what? Differentiation of functions. Remember, differentiate a function with respect to differentiate a function. I revised it in the previous session. I did a revision of this as well. I have taught this in detail as well in the in your series which is going for your continuing differentiability. Check all the sessions. This is there. You can find the topics there. Find it there. Okay. So in the differentiability section, I have taught this. When I can differentiate one of the function, it was in actually parametric form. Please check here. Subheading will be parametric form. When I can differentiate this with respect to this. Okay. So what did I do? If you remember, I have to find dy by dx, but there is a parameter here theta theta. So to find dy by dx, I'll do what, bacha? To find this value, I used to do what, bacha? dy by d theta upon dx by d theta. Right, na? Correct, right? Let's find dy by d theta. First, how much I get? I keep a as it is. This will become what, bacha? 3 sine square theta, and this will what will become? Sine theta will be simply cos theta. Please understand this. A as it is. This is sine cube, so polynomial formula will be active. 3 sine square theta, and for sine I'll get cos. So this is done. What about next one? Dx by d theta. I'll do for this. I'll keep a as it is. Same way, 3 cos square theta, and this will be what, bacha? Minus sine theta. Differentiation of cos is minus sine theta. Minus sine theta. I want the ratio, right? Okay. I want the ratio of these two, right? How can I get the ratio of these two? If I get the ratio of these two, if I divide them, I can do it over here only. Please see. If I divide them, a and a will cancel. 3 and 3 will cancel. Okay. This cos will cancel with one of the cos here, and this sine will cancel with one of the sine here. What is left now? Please check. It's simply one sine in the numerator is left, and over here I have one cos left. Is that all? No, sir. There's a minus sign here also. So minus this thing. How much is that? Basically minus tan theta. Minus tan theta. This is my, what is it? dy by dx. Why, sir? I have used as division over here. Use this as division over here. If I do that, what I'm going to get? Please check. I'm asked to do this. 1 plus dy by dx the whole square. 1 plus, what is dy by dx? Minus tan theta the whole square. Simply plus tan square theta. Please understand this. Negative will become positive, tan square theta. How much is that? Secant square theta. Secant square theta, which option? Option D. Please have a look. Please have a look. Okay. I wrote for parametric form this expression. For dy by dx, I found dy by d theta, dx by d theta. Use the division, cancel the which thing which is common. Negative sign was there. Square theta becomes positive. The identity I have used here, 1 plus tan square, is sec square. Option D is correct. Moving on. Okay. Problem number 7th. Again, application of determinant is there. Find P first. Simplify this here. Find P first. Find P first. So they are saying P is this, Q is this. Find dq by dx. Again, what I'm going to do? I have to find dq by dx. So first only differentiate this. You'll have to get what? If you simplify this determinant, you'll get in terms of x. No, you'll get expression in terms of x. Algebraic expression. Now, if you take the differentiation of that, will this be any of the option? We have to check that. So let's find for P first. How much is that? X square minus 1. Correct. What about this? What about this? I have to do with what? Plus, minus, and plus sign. I hope you remember, first one is positive because number of term. What is the row and column? 1 and 1, so even. 1 and 2, so odd, so negative. 1 and 3, so even again, so negative. What is 1 and 3, sir? I'm talking about this. A11, A12, and A13. Okay. I taught in determinant. 1 is even, 1 2 is odd, so negative. 1 3 is even again, so positive. Right? Yes. Let's do the determinant of Q again. How will this look like? For x, if I'm doing, I'm going to get as what? X square minus 1. Correct? Okay, for 1 if I'm doing, I'll cancel this. I'll get it as x minus 1. So minus 1 times this here. X into 1 is x, and this is simply 1. So x minus 1. For the last one, if I'm doing plus 1, Please check. What I'm doing for plus 1, I'll cancel the third column. I'll neglect the third column. I'll get it as 1 minus x. Please check here. 1 times of minus x. 1 minus x. Understand this? This minus this. So 1 minus x. Simplify it over here. Get it as q equals to what, bachcha? X cube minus x. Over here what I'm going to get? Minus x plus 1. See? Minus x plus 1. Over here what I'm going to get? Plus 1 minus x. Simplify it. I'm getting q as x cube minus x minus x minus x. So x cube minus 3x, and I'm getting plus 1, so plus 2. X cube minus 3x plus 2. Differentiate with respect to what, बच्चा? X. कर लेंगे. Simple, right? dq by dx नहीं होगा. Please check. X cube minus x minus x minus x is minus 3x. 1 plus 1 is 2. Polynomial expression I'm getting. I'll differentiate with respect to x. I'll get here what? 3x square minus 3. Correct? And plus 0, so I don't have to write that. Plus 2 will become plus 0. Take here 3 common. I'll get what? X square minus 1. How much is that? Simply dq by dx correct? Simply what is it? 3 times of p. Please check here. What is p? Okay, option number B. Option number B is my correct answer. Simple, very, very simple. Let's move on. Okay, now I don't have to do this. The question is asked. Please check here. How do we solve it, sir? Remember this graph. The graph of GIF, What's GIF, sir? GIF is bachcha your greatest integer function, right? Yes. The tail is always including, the head is always excluding. Please check here. Tail is including, head is always excluding. Step function or greatest integer function. They are saying that please check it is continuous at minus 2. Is it continuous? No, sir. There is a break. On the right of minus 2, it's coming as minus 2. Over here, it's coming as minus 3. If I go towards left of minus 2, it's minus 3. Towards right, if I go, it's minus 2. So, no. What about 4? No. What about 1? No. How, sir? I told you, when I was teaching you this part, at limits I was doing, no? At what you call integral value. At all the integral value, write it as I or z, whether plus or z minus, anything, okay, even at 0. So what happens is, the function, the GIF, the greatest integer function, has 2 different values. So different means on the left it has different value, on the right it has different value. So limit will not exist. So at this point what happens? Limit does not exist, sir. Because left hand value is different, right hand value is different. RHL and LHL are different. So only at this value you will have this as correct. Please check here. 1.5 will come where, bachcha? This is 1. 1.5 will be here. 1.5 will be here. Right of 1.5, what is the answer? Please check. 1 only. Right of 1.5, 1. Left of 1.5. So what I'm saying is, when x tends to 1.5 from positive side, what is the limit? What is my RHL? RHL is 1. If x tends to what value? 1.5 from left hand side, it will be what? 1 again. This is my LHL. So both LHL and RHL are 1 and 1. So at 1.5 the function is continuous. Clear? Okay. Moving on. 9th problem. Okay. X power y, e power x minus y, dy by dx to identify. If you don't use the concept that I taught you, it will become very complicated. What did I teach you? Whenever we have product, exponent or quotient of the variables, you can use directly what? Logarithms. Use it. See what happens. Use log over here. You have to find what? dy by dx. You have to find dy by dx निकालना है. Use log here. So use log with the base e, because there is a e here. So log with the base e you use. Log with the base e, which is, what is this called as? I taught you logarithms. It's called as natural log. So log with the base a is natural log. X to the power y equals to log with the base e to the power x minus y. Correct? Correct? This y will come here. What I'm going to get? Y plus, sorry, not plus, right? It'll come as coefficient, no? It'll come as coefficient. So I'll get it as y log x to the base e. Correct? Over here I'll get what? X minus y log e to the base e. Correct, na? Because this part will move as coefficient and this e will remain as it is. What is log a to a? Option always 1. This part is 1, right? Log e to a is 1. Log e to a is 1. So what I'm gonna get this as? I can write this as just simply log. I'm going to write base. So y log x, I can write it here. Y log x equals to what, bacha? Simply x minus y. Why, sir? Because log e to base e is 1. Log e to base e is 1. Okay. Now I have this expression. Please check. Please check. I have this as y log x equals to x minus y. Correct? Differentiate it. So y, if I'm differentiating, I have to use here what? Product rule I have to use here. Product rule. So use first, keep y as it is. Use for log x. I'll get it as 1 by x. Now keep here what? Log x as it is. Use for y. I'll get it as dy by dx. Please understand this. I kept y as it is. Differentiated log x, 1 by x. I kept log x as it is. Differentiated y. So dy by dx. What is this equals to? 1 minus dy by dx. For x it is 1. For y it is dy by dx. So keep the dy by dx term on one side. So I'll bring it over here and bring that over there. So please see how will this work out. So log of x multiplied with dy by dx plus dy by dx. Correct, now this is coming here, and 1, this will go here, minus y upon x. Please see this. 1 will remain as it is. This is going moving, y by x will move there. This is y by x, no? Move here, becomes minus y by x. Okay. So I can take dy by dx here common. If I do that, what I'm going to get? Please see, I'll get it as log x plus 1. I get it as log x plus 1 equals to what, bacha? X minus y upon x. I've taken LCM. Simple. X minus y upon x. Okay. Next step, what I'm going to do, I'll bring this in the denominator. So please check how will this look like. Please check. देखिए. Okay. I'll write it as x minus y upon x log x plus 1. X minus y upon x times of, this is in numerator, over here comes, it becomes denominator, so log x plus 1. Correct? What is my value of x minus y? Please check from here. Y log x. Y log x. So right here, please. Y log x is the numerator now, and this is simply x log x plus 1. If you're asking why, because this is my x minus y value. X minus y value. And what is x value? Simply y log x plus y. This is my x value, right, from here. Please check. I've taken this y on this side, taken this y, negative y on this side becomes plus y. So x is nothing but y log x plus y. I can rewrite in place of x like this. Please see. So y log x upon, what is it? What is it? Y log x plus y. Y log x plus y. This is written in place of x, only in place of x. Okay. I'm writing this if you want to know. This is my x value. Okay. This is my x value. Now please continue. Multiplied with log x plus 1. Log x plus 1. Okay. Please write it here. Y log x upon, take here y common. Take here y common. Y will be log x plus 1 and log x plus 1. Okay. I can cancel this y and y. What is my dy by dx now? Log x upon simply this 1 plus log x the, or log x plus 1 the whole square. Any option like this? Option C. Log x upon 1 plus log x the whole square. Please check. Please check. Okay, let's move on. Question number 10. Okay, x power m y power n x plus y power m plus n divided by dx. What is the approach again? The approach is very similar. Take log on both sides. Take log on both sides. Asked in 2016. Okay, if I take log on both sides, what will this be? Log of x power m y power n equals to log of x plus y power m plus n. Okay, why I'm not taking with e in this case? I can take with any number, no, in this case, because what happens, bacha, in the previous case it was given as log with the base e. The e was given as the base, so I took it as log with the base e, okay, to cancel the effect. But in this case it will not come like that. So for that reason I'm not taking with the base e or any base. Doesn't matter with the any base, the answer will come as it is. So no requirement of that. What is the formula here? Log of a plus b. Log of, so log a into log b, right? So it will become log of x to the power m plus log of y to the power n equals to what this will be? M plus n will come in out as the coefficient and log of x plus y. Do not write it as log x plus log y. Don't write it as log x plus log y. That's incorrect. Only for product the rule is there, not for the sum. Okay, it's called as product rule, not the sum rule. You cannot separate this as log x plus log y. In the exam, what happens? No, even if you know this right, you'll make this mistake because you have time constraint. You'll think, okay, this is easy, I'm getting steps, but incorrect. Take this m here, I'll get it as m log x. This will be n log y. N log y. This will be nothing we can do over here. What comes next? Next is differentiation. We are looking to find what value? Looking to find the value of dy by dx. Okay, चलिए करते हैं. Next slide. M log x plus n log y equals to m plus n log of x plus y. X plus y. Please check here. Yes, sir. Yes, sir. Okay. Differentiate it, bacha. M as it is, it becomes 1 by x over here, and as it will become 1 by y dy by dx. For x it was 1, so I don't write it like this. I don't have to write it. But for y I have to write what? Dy by dx. For y I have to write what? Dy by dx. M plus n is a constant. I can keep it out. Okay. What about this part? 1 upon x plus y. Is it over, sir? No, sir. I have to use chain rule, no? But with what? Expansion. So this will be simply 1 and then dy by dx. How, sir? Please check here. For x it is 1, for y it is dy by dx. Okay. This is what simply m by x plus n by y dy by dx. Okay. Yes, equals to what, bacha? M plus n upon, I can write it like this, x plus y. Okay, and this bracket will be 1 plus dy by dx. I hope this is clear. Please check. Please check. M by x, n by y, dy by dx, m plus n. This is coming as denominator over here, 1 plus dy by dx. Expansion over here. M by x plus n by y, dy by dx equals to what? Expand here. Right, I've done the expansion for the bracket. Bring this term over here and this term over there. What will this be? M by x minus m plus n upon x plus y equals to what, bacha? Please check. Dy by dx times of what? M plus n upon x plus y minus this one. Nyy dy by dx, sir. Correct, no? Correct, right? Correct, no? Simple. Just, I've switched the terms here. With the plus becomes negative and this plus becomes negative there. So I will take the LCM over here. So what is the LCM? X times of xy. This is not alpha. This is x only. Looks like alpha, but it is x only. So x times of x plus y. X times of x plus y. If I do that, what I'm going to get? Please check here. Okay. How will this look like? I have to multiply this x plus y over here. So m times of x plus y. What next? X times of m plus n. Correct? I'm doing what? Cross multiplication. x plus y with this and x with this. Please check. Please check. X plus y with this m and x with m plus n. Right? This is done. What about RHS? Take first dy by dx common. What is left now? I think, right? N by y, m plus n upon x plus y. Correct, sir. Okay. Just expand here. I'll get it here. mx plus my, mx plus my minus mx minus nx upon x times of x plus y. Take again here also the same thing. I'll take the LCM as x plus y times y. Okay, x plus y times y. How much is this, bacha? Multiply y over here, so y times of m plus n minus n times of x plus y. Okay, something getting cancelled, sir. Please check this step now. mx with mx is cancelled. I have what? I have my minus ny, nx. Okay, I have my minus nx upon x, and what I have here? dy by dx. See here, I get what? If I expand it, my plus ny minus, this is what? This is my n, right? This is my n. So nx minus ny upon y. nx upon minus ny. Okay? Anything can be cancelled? ny cancelled. Please check here. I have here as my minus nx upon x equals to dy by dx. What is this, bacha? my minus nx. This is my minus nx. Please check now. Please check now. Cancel. Okay. I can just bring this y over here. So I can write it over here in this step. Last step. Please check. I know the question was longer, but some questions will be like this. Okay. You cannot expect all the questions to be very, very simple. So what I'm getting here, just 1 by x is there. What I'm getting here, dy by dx is there. This is simply 1 by y, correct? 1 by y. Bring it over here. So y by x equals to d by y dx. Okay. I know the question steps are more. I have taken more steps, okay, actually, to make sure that you're not missing anything. But if you can do it in a very simple step, writing 2-3 steps also, 4 steps also, good, no? Good for you. So make sure that you have the answer as D. Have the answer as D. Okay. If you can do in the less steps, very good, bacha. Okay. I cannot skip it because some students might not, be able to understand if I write in less steps. So for that reason, I'm writing all the steps. You can, cancel. You can identify and cancel from there only. You can see in your mind if you can cancel. Good. Over here, you can identify here. M plus n will come here, sir. This will be like this. You don't have to write all these steps. Directly, you can write this step. Skip these 2 steps. You can write this step directly over here. Then what you can do? Take the LCM this step, and then don't have to write this step. Okay, you can write this step directly and then cancel also in your mind. You will get my final answer. So I am saying that you don't have to write these steps directly. You can write this step. You can just directly don't have to write this step. The last one don't have to write this. Directly write this step. Okay, and then you can just cancel in your mind and then get your answer as y by x. Y by x. But if you are not able to do that, if you can get, because simple question but lengthier. Simple question but lengthier. Okay, so make sure that you solve everything. 11th problem, tan inverse of x square plus y square equals to alpha, dy by dx is equal to. So I have not taken all the PYQs, I have taken only some. Most other PYQs will come in your mocks, KPL 3, not KPL 3, I think 4 will come. It will come in the 4 or 3, both of them. I think some of the questions from the PYQ will be in the 3rd mock with the continued differentiability, and the other one will be for the next mock. Okay. So every chapter, every mock is coming with what? Multiple chapters. So okay. So second mock of this chapter will again come. Chaliye, let's move on. Tan inverse of x square plus y square. Tan inverse of x square plus y square equals to alpha. Find dy by dx. Okay. So can I simplify this? Yes, I can. Check here, please. How will I do that, sir? Any idea? I think you will have some ideas, right? I can take tan on that side. I'll get what? I'll become what? Will become what? Tan alpha. Okay. What is the variable here? Is alpha a variable here? No. Alpha is not a variable, it's a constant. So if I differentiate, it will become 0. That's why we did that. Now let's take differentiation of this. So it will become 2x plus 2y dy by dx. Okay, dy by dx equals to what, bacha? 0. Okay, 0. Bring it over there. I'll get 2y dy by dx equals to minus 2x. Minus 2x. So now what is my dy by dx value from here only? Please check. Minus 2x upon 2y. 2 and 2 goes out. How much is that? Minus x upon y. Minus x upon y. Option A. Simple question. I said no. Previous question took a lot of time. Not every question will be like that. And one more thing. What is happening? No, I am taking the same chapter. So if the chapter is lesser lengthier, every question is lengthier. But in the examination, what will happen? You'll have mix of all chapters. So if some chapter is coming, if they are giving difficult question, they'll also give what? Simpler questions. Remember the ratio, the standard of this 50, 30 and 20. 50% questions is very simple. 30% is little bit difficult, moderate kind. 20% are the difficult problems. Okay. So you will have that balance. Chaliye. Okay. Now what about this tan inverse of sin x plus cos x? Cos x minus sin x, then dy by dx equals to what? Okay. Okay. Let's do it, sir. So if to operate this tan over here, I need what? Please check. To operate tan inverse over here, not tan, I need a tan in the bracket also. How can I make tan? If I divide by cos, if I divide both numerator and denominator by cos, it will become sin by cos, so tan, and cos by cos will be 1. Okay. This will be again cos by cos, so 1, and this will be tan again. So maybe something will work out. Let's do one thing. Let's just take this expression first. Okay, I have enough space. I'm trying to do this, please check. Sin x plus cos x divided by whole thing by cos x, and same with the denominator also. Same with the denominator also, cos x minus sin x upon cos x. Whatever is the effect you are taking, you have to take for both the side, right? Both numerator and denominator. Okay, both LHS and RHS, whatever it is, you have to check for both sides. Effect is divided by cos x. So I'm going to do that now. Please check here. Sin by cos, so tan, and cos by cos, so 1. I have to divide with both the terms, right? Sin x by cos x, so tan, and this is simply 1, not alpha, this is x. Okay. This cos is gone now. What about this denominator part? Cos by cos, so 1, cos by cos, so 1, and this is my sin by cos, so tan. Okay, let's do it in this step now. Tan inverse of what, bacha? What did I get? 1 plus tan x upon 1 minus tan x. Is it right? Correct. Now if you remember, there was a formula I used in the previous few questions also, one question also. I think we have used it in multiple sessions. So tan inverse of, I think we've used in the previous session. Okay, tan inverse of what? If it is a plus b upon a minus b, sorry, not a minus b, 1 minus ab, right? 1 minus ab, then this will become what, bacha? Tan inverse of a plus tan inverse of b. Am I right? Okay. We don't have that, but I can write this 1 as tan inverse of or tan of pi by 4. Now see how the question will change. Tan inverse, write this as tan of pi by 4. How much is that? Tan 45 is 1 plus tan of x, it is tan of x, okay? Tan of x upon, I can write this as tan pi by 4 times tan of x. Please understand this? Yes, nothing is there. I can multiply 1 to it, no, and 1 can be written as tan pi by 4. Okay, so simply this question will become what? This expression will become what? Tan of pi by 4 plus x. Yes or no? Yes or no? Yes, sir. Tan A, tan B, 1 minus tan A, tan B. Okay, it becomes what? Tan inverse of this. Okay, So tan inverse of this will be what, bacha? Tell me. Simply tan inverse of tan. Simply this pi by 4 plus x. What are they asking us to find? dy by dx. dy by dx. Find it here. 0 plus 1. For 5 by 4 is a constant, so 0. For x it is 1. How much is the answer? Okay. Alright. Answer is D. Yes. Answer is D. Okay. I hope this was it. Yes. So we have covered another session. What was it? It was based upon P by Q. So this completes your continuity and differentiability. Next session after your mock, you will have what on? You will have on application of derivative. Okay. So I hope this was, this whole chapter, this series for this particular chapter, continuity and differentiability, was helpful. Any doubt, anything you want me to add on this, please make sure that you comment below. If you have any requirements, I would see how you can justify this. If it is okay, if it is good, I will come up with a session to clear your doubts in that part. Whatever it is, make sure that you comment below so that I'm able to respond to that and we can complete our entire chapter totally. Okay. So now this is coming. Next will be your KPL. Prepared for it, be prepared for it, determinant, and this chapter will again come. Less questions from here, but more on determinant you can expect. Okay. With this, I would like to end the session. Take care of yourself, keep working hard, keep solving questions, and maintain a positivity in your face, maintain the smile on your face. For today, that's all. Thank you. Take care. Bye-bye.